Hey everyone. Today I wanted to make a video to show you a little trick that I just sort of put together for fixing the temporal shimmering that you get when using the denoiser in Blender on animations. So if you're unfamiliar what I'm talking about, let me just show you here. This is a little animation clip that I made to just sort of showcase what I'm talking about. And you'll notice um, there's a lot of shimmery artifacts here caused by the denoiser in Blender. Of course, I'm using open image denoise. I don't know how bad this is with optics denoiser, but that just doesn't seem to work on Linux, so I'm using open image denoise instead. But in open image denoise, you can tell there's definitely quite a few denoising artifacts going on, especially here on the monkey's face. I designed this scene specifically to be as noise heavy and uh uh yeah, basically be as noise heavy as possible to basically really stress the denoiser so that these artifacts are clearly visible. But once we're done, we'll get a result that looks like this. So this is all the same rendered frames. I didn't re-render this at all. It's the same animation as before, but using this little trick that I worked out, I was able to stabilize the shimmering artifacts quite a bit. It's not perfect. As you can see, there's still some in the monkey's face, and there's a few going on with the glass monkey over here. But generally speaking, this is a much better result than what we were looking at just a moment ago. I'll play that again just so you can see. Okay, so this is the original, and then here's the stabilized one. So to do this, we're going to go into Blender. I just created a new scene. So you're doing this after you finished rendering. Um, because we're going to be doing this in the compositor, and you need the whole animation to already be rendered to do this. So I'm going to delete that render layers node here, so it's just the output. If your compositor layout looks a little different than mine, just drag a window out here and I have it set to image editor and then this set to render result. So basically, we can see what we're working with over here. I don't really like viewer nodes. I don't like them in the background behind the nodes. It just seems kind of visually busy to me. I don't like it. And so I'm going to add in the animation that I did, and mine is in image sequences. If it's a video clip, then you'll just import it as a movie clip. I'm going to select image sequences. I'm going to go to where my frames are and select them all. I'm going to drag it over to the output. If I hit render image now, you'll see it's here. I rendered this at half resolution, so I'm going to change the resolution to half resolution. That way it takes up the whole image. So what we're going to want to do is we're going to want to make two duplicates here of our clip. I'm going to put one above and one below. For the one above, I'm going to offset it by -1, and the one below offset by +1. So we basically have three different frames here. If I go to this, because we're on frame 1, it's just going to show an empty frame. But if I go to frame 2 or frame 3 and drag these around, you'll notice they are all on different frames now, which is exactly what we want. Because what we're going to be doing is we're basically going to find the average between all of these images, and then we're going to blend that with the original frames, uh, based on how similar they are to those original frames. Is we're going to have a threshold that says, okay, these colors are close enough, so blend them. And I'm going to set my view transform to sRGB. If you're probably you're going to want to do this to make sure your colors are accurate, because by default it'll probably be set to filmic or something else. For you, it's probably going to say standard because I'm using a custom Aces color space, and that changes the the standard view transform to be sRGB instead. So for this, you just set it to standard. That way you get your proper colors. If you're working with EXR files, you won't have to worry about this, since those are, not, those don't have to worry about color management because they are non-linear, whatever, they are linear, whatever. I'm not going to get into all that. Color spaces are complicated. So we're going to do, so we're going to create a mix color node here, and we're going to mix our frames. We're going to set it to add. You'll notice this is going to really brighten it up. And that's fine, because we're going to fix it afterwards. Duplicate the add, drag our third frame in there. And as you can see, we have all these frames added together. And to get the brightness back down to its original value, I'm going to duplicate this node a third time, set it to divide, and then input constant value. Because we are merging 3 frames together, the value is going to be 3. So if we divide it by 3, it is now back to the original brightness. So for comparison, there's the original. Here they are blended together. And already, this has gotten rid of a lot of the instability, but now we have a new problem. We can see basically the other frames in here, because it's basically like we're just blending the frames together. So, and also I need to set this to only be 72 because that's how many frames are in my animation. But yeah, that doesn't look good because we don't want that, but we're gonna fix that. So to fix that, I'm going to duplicate this add node here again, and the blending mode I'm going to set to difference. So now we'll drag the output from our middle frame to the top one, and the output from the -1 frame to bottom output. If I drag this into composite, now we can see where all of the differences between these frames are. You'll notice that where things are moving is where the most brightness is, and where things roughly stay the same is where things are most darkest. And this is exactly what we're looking for. And then all of this here, you can see all this sort of colorful stuff going on here. That is all of the shimmering artifacts from the Denoiser, and there's a bit more over here too. But we basically isolated all of the things that are different between frames. And now we're going to get a utility math node, and we're going to set this to less than, or no, greater than, no, less than. And you'll see that that changes this whole thing to be white, except for these few little spots here. Basically what this node is it's checking every pixel, and it's checking its brightness to see if it's above this number. So this will be our threshold. And since, like I said, with how the difference works before, is that uh, darker parts are where things are most similar, and the lighter parts are where things are the most different between frames. You'll see that the very most different parts are now black. So, what we can do is we can add an input constant value, and we're going to use this as our threshold. Plug that right into the threshold. We won't see any difference at first, but if we change this down to, say, 0.1, hey, now we're starting to see those edges that were bright before, or at least more of them than we did before we put this in. And you can just play around with this, see what gives you the best results. Typically, I would say something around 0.05 will work best. This animation specifically has a very lot of it has an extreme amount of denoising artifacts because I specifically rendered it to have as many as possible to make it as artifacty and gross looking as possible, just to as a demonstration. But if you're working with an actual animation that you've put together and you've rendered it at a higher resolution with a higher sample count, because I only rendered that at um like 60 samples. I deliberately kept the sample count low to really stress the denoiser. So, but if you're doing a full proper render, then you'll be able to go much lower with this value without with it still functioning properly. And so now I'm going to duplicate these two nodes again. And I should have mentioned it earlier, it's Shift-D to duplicate. At least that's what it is in the I'm using Blender 2.79 shortcuts because I've been using Blender for 10 years or so, and I am so used to those shortcuts that changing to the current ones is still not something I am comfortable doing. I'm just so used to them. Anyway, we're going to do the same as we did with these ones up here. So we're going to take our middle frame and connect it to the first image input, and then our +1 frame into the bottom. And now we have the differences between this frame and the middle frame. Let's drag our threshold value in again. And now all we need to do is combine these. And to do that, we're going to set this to multiply, since we're just going to make everything that's black combine and everything that's not combine. And now we get a result like this. And if I scrub through the frames, you can now see that we're basically mixing together all of the parts of each frame that are different. And we've created a mask to basically remove these sort of edges from our rendered image because they are very obviously different from what we want. And we don't want them to be visible because as you saw before, now we get stuff like this going on, which obviously we don't want. And now we can get rid of them. So we're going to create another mix color node. We're going to drop this into the factor, and since black is where the differences are, we're just going to take our middle frame and bring that into the first input there. And then we're going to take the result of our averaging of the frames and plug that into the bottom. And now, you'll notice those artifacts are gone, but we've still retained our much better temporal stability. There are a few issues, as you'll notice here, um, where the harsh edges of our math nodes have left some jagged edges here. That's simple to fix. We can just add a soften node here, and that'll soften up those edges. And now it's much less noticeable. And of course, if you're using a lower threshold value and you're rendering things at a higher resolution with higher sample counts and stuff, you won't have to deal with this problem because um the lower the threshold is, the less things like this are going to pop through. But anyway, now that we have that done, we've basically created our entire setup here. All right, so post-recording, I'm back because I noticed I needed to add a little addendum here. One thing I forgot to mention is that if we go to the first and last frames of our animation, you'll notice yeah, there's these sort of harsh edges here. And that's because if I go back to the first one, you'll notice our -1 frame is now empty because it doesn't have a frame to pull from. And so to fix this is pretty simple. We're just gonna have to animate our division value. And it's like, since this is no longer being added, we are only blending between 2 frames. So on our first frame, we're going to want to have this be set to 2, and I'm going to animate this by hovering over it and pressing the I key. Again, not sure if that's different in the newer Blender shortcuts. And then we go to the next frame, and on frame 2, we just set it back to 3. Hit I again to set the keyframes, and now we've fixed the issue at the start. Go back to the end here, set it to 2. I go back 1 frame, set it to 3. I. And so now we've basically fixed it so that the first and last frames no longer have this issue. So I am going to select all of these nodes, and I'm going to hit Control G to make a group. And so now we have our node group here. For set to image. I'm going to modify this node group and get it all set up to have all the proper named inputs and stuff. And I'll probably link this node group in the description so that if you don't want to follow along with the tutorial and you just want to use the node setup that I've created here, you're free to do that. But I figured I would show the methodology behind it, just so that people know how it works. I figure that's something I wish more people would do, is just explain how they put together these sorts of node groups when they just, most of the time they just link a download. And I figured this would be useful information. I hope to all of you out there who do cycles renders, this is helpful to you. I don't think it'll be very helpful if you're using Eevee, but if you use cycles and you use denoising, then it'll definitely show an improvement. Some things I should note about this method is if you have fast moving objects, like let's say the Suzanne here, if I were animating it, if in one frame it's here and then on the next frame it's here, because there's going to be little overlap between the colors, it's not going to do a very good job at temporally stabilizing the denoising artifacts because the frames will be so different because the object will be in such a different place that that doesn't work. But that shouldn't be a big problem anyway, because if an object is moving fast, it's probably not gonna you're visually not gonna notice the artifacts as much anyway. So I'm not too concerned about that. It's usually just for when things are more still, but not like perfectly still. Like how the camera in this animation um just sort of hovers around in place. It isn't perfectly still. It's moving around a little bit. Stuff like that is going to trip up the denoiser and cause artifacts. But uh, but for fast moving objects, it's probably not going to be an issue anyway. And just for comparison's sake, again, uh, also I forgot to fix the colors for this one, so the colors are a little messed up on the original here compared to the one that I fixed here. Um, but yeah, I guess another way that we can compare this is here's the original frame. You can see it almost looks like JPEG artifacting, but it's like different color weirdness going on here, and there's much less of it here. And yeah, that's just a little technique that I figured out and I figured I'd share. So hopefully it comes in handy for you. Uh, Thanks for watching, and I guess I'll see y'all next time.